Hi everyone, thanks for attending the session. My name is Yann Rapaport. I'm SixWind's product manager. SixWind is a high-performance packet processing software company. And here today, I'm going to demonstrate our SixWind Virtual Accelerator product, how it accelerates an OpenStack environment configured to use Calico. So for those of you who don't know Calico, Calico provides L3 virtual networking for high-scale data centers. So it's an open source project that uses Linux forwarding and BGP for connectivity to, from, and between VMs. Calico is an alternative to L2 virtual switching with OVS or Linux Bridge. It's just a different approach. It doesn't use overlays. And Calico is integrated with OpenStack. In the demo, we will show how SixWind Virtual Accelerator accelerates the hypervisor performance. It's easy to install in OpenStack environment. It's transparent to the environment. There is no change required to the OpenStack environment or to Calico configuration. And we will see, of course, the performance boost brought by Virtual Accelerator. So we will have a demonstration in two parts. We have a system with two compute nodes. These compute nodes are running on Intel E5 2690 V3 CPUs at 2.6 gigahertz. So it's a 12-core, 24-thread CPU. We have the OpenStack Mitaka environment configured, and we have one virtual machine running on top of each compute node. The compute nodes are connected using 40 gig NICs, and we will, of course, Calico is configured in the environment, so to provide L3 connectivity between the VMs, and we will measure the performance of this environment. So the first test we will do is an IP throughput test using iPerf, so between one VM and the other. And then we will do another one. We will evaluate HTTP request rate using an Nginx server and Apache Bench. So that will be a first step in a standard Linux environment to have a reference. And then in the same system, we will very easily, as you will see, install Virtual Accelerator and then do the same test. So there is no change to the Calico configuration. There is no change to the environment. We run iPerf again. We run Nginx and Apache Bench again, and we see the results. So let's get started with the demo. So we look at one compute node here. We see Calico is installed. Calico uses Bird as the control plane for routing. We see also that OpenStack Mitaka is installed in the system. So we are going to configure the system. So we create networks for the virtual machines. We will have two networks. On each compute node, we have one network for each virtual machine. And we start the workloads. So we use Nova Boot to boot the two VMs. The VMs are started. The environment is configured. And you can see that on the compute node, IP routing is used. And also IP sets, so ACLs, to configure the connectivity. So it's pure L3 environment for the connectivity between our two VMs. So we have this running now. You see, so on the top right, VM1, on the bottom right, VM2. The two VMs have started, and we are going to benchmark the performance between these VMs. We run iPerf server on VM2, iPerf client on VM1, and we check the performance. So here, standard Linux, there is no acceleration. The IP throughput between the two VMs is 14 gigabit per second. It's using all the Linux cores in the compute nodes. There is no specific configuration of the Linux CPUs. And so we see this first result. Second step of our first part, we will do a HTTP request benchmark. So we start Nginx on VM2. We start it. And we are going to start Apache Bench, a benchmark tool, a well-known benchmark tool to check the HTTP request performance. And so we see with Apache Bench that we obtain almost 19K requests per second. So again, standard configuration. This is just Linux running, and we have this performance. So 14 gigabit per second of throughput and 18K HTTP requests per second. So now we are ready to go to the second part of our demo. So we clean up a bit the environment, we stop the VMs, and we are going to install Virtual Accelerator. So Virtual Accelerator, it's a Linux application. It comes as a package that you install into your environment, so depending on your distribution. So here we are installing the credentials, we are installing the 6Wind repository so that we can just use Yum. We update Yum cache, and we will use Yum to install Virtual Accelerator in the system. So that's in progress. You can see the cache is being updated, and Virtual Accelerator will be installed on Compute 1 and Compute 2. That's happening at the moment. Then Virtual Accelerator is a standard service in your Linux environment, so we enable it. We restart libvirt, we restart OpenStack Compute to take the presence of Virtual Accelerator into account. There is no change to the configuration of the system, no change to the IP configuration of Calico. This is not required. You can see, I'm not sure you can see it, but I can tell you, so Virtual Accelerator is started by default on one core per NUMA node, and it pulls the NICs that are connected to this NUMA node. That's the default configuration. This can be changed, but in this test, we will use just one core, 2 threads. So Virtual Accelerator is started. One last step is to install 6Wind's OpenStack extensions, just to make sure that Nova is not going to use our dataplane CPUs. We use dedicated CPUs to guarantee the performance, to have predictable performance, and we don't want Nova to schedule workloads on these CPUs, so we have an OpenStack extension for this. So the system is now ready, so no change to the environment, no change to Calico. We are going to run exactly the test we ran before. So we have to start our VMs. We start VM1, we start VM2. The VMs use huge pages to benefit from 6Wind high performance VNIC backend, and in the VM it's a standard VirtIO, so there is no change to the VM itself. And now you can see iPerf is being started. So on VM2 iPerf server, on VM1 iPerf client, so it's exactly the same test as before. And we check the performance. So now we have 23 gigabit per second, so that's 2 times Linux throughput, again using just one core of Virtual Accelerator, whereas before all the cores of Linux were used for your virtual networking. Here just one core allows to get 2 times the throughput. And we can move on with the HTTP benchmark test. We start Nginx on VM2, we start Apache Bench on VM1, and so compared to 18K requests per second, now we see 61K requests per second, so that's 3 times the rate, again with one core used for your virtual networking part. So that's the end of this basic demo. So as a summary of what we have seen, we have demonstrated in an OpenStack environment, OpenStack Mitaka, configured to use Calico, L3 networking for the connectivity between your VMs. And we have used Virtual Accelerator to accelerate the hypervisor performance. We have compared standard Linux versus Linux running Virtual Accelerator. With Virtual Accelerator on one core versus Linux running on all cores, we see 2 times the throughput performance for the VM to VM communication, and we see 3 times the HTTP request rate. We have also demonstrated how easy it is to install Virtual Accelerator in your environment using your standard package manager. If you use Fuel for your OpenStack deployments or Juju, we also support the Fuel plugin and the Juju charm for Virtual Accelerator. So we are really transparent to the environment, and as you have seen, there is also no change to the Calico configuration. That's it for my demo today. Thanks for listening to the session.